Okay, today in IM1 we're going to talk about parallel and perpendicular lines. This is section 4.3 in Big Ideas. To sell at the farmer's market for a year, there's a $100 membership fee plus a $3 fee for each hour that you sell at the market. What is the equation of this line? So think about it. Put it in slope-intercept form. Start with your y equals. Remember, what is your per cost? So it's per hour, so we're going to put that there. So x must be hours. Okay, and there's that $100 fee to join. So there's your equation. This would be my total cost. All right. Now, if you were a member the previous year, the membership fee is only $50. So what would be the equation for that line? It would be very similar, except that the fee would only be 50. Okay, now we're going to graph those lines and look at them, and what do you notice about the two lines? So hopefully what you noticed is that these two lines are parallel. And if we wanted to show that, we would put a little symbol like that. That would show that they are parallel. They are in the same plane. They have no points in common. In other words, they do not and will not ever intersect. So if you look again, what do you notice about the equations of these two lines? We know that they are parallel lines. What do you notice about the equations? Hopefully you noticed that they have the same slope. So here's the rule. Two lines in the same plane that never intersect are parallel lines. Two distinct non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel. Okay? So all vertical lines. So I could draw a line here or here. They would all be parallel. The same is true of horizontal lines. I don't know why they didn't include that, but all horizontal lines are parallel to each other. These two are parallel. Notice they have the same slope. Okay? All right, so we're going to determine which of the lines, if any, are parallel. You can use the slope formula. For example, for this one, I could say -1 minus 2 over -2 minus -1. That's -3 over -1. And so that's a slope of 3. Or we could do our triangle. And I see I have a slope of 3 over 1. I can go to this one. 1, 2, 3. Oh, that one has a slope of 4. Don't be fooled by the picture. Over 1. So these are not parallel. Let's look at this one. Whoops. And this one is also 4 over 1. So these are the two that are parallel. Okay, B and C. B is parallel to C. Okay, go over here. You can do the same thing. My slope on this one, this is the one I don't think is parallel, so I'm going to do that one first. It's 2 over 1. And I'm going to do my slope of this one. And it is 1, 2, 3, 4, 1, 2. So it's 4 over 2. It's also negative, so it's -2. Let's see how this one looks. Find a point. You want to make sure you're at a point where lines intersect. So there's a point there, there's a point there, there's a point there. Oh, they gave us 2 points, so we'll just do this. And I get 2 over 1. It's also negative. Remember, you might not look the same, but the final answer is the same. So A is parallel to C. Okay, and that's how we write it. All right, so if you were going to identify by just looking at the equation, you're going to look at the slope. So I can see this slope and this slope are the same. And now be careful, so these two lines are parallel. But what is the slope of this one? It's 1. And the slope of this one is 1. So this one and this one are parallel. Okay? So always watch out for that. And there's your lines. And you can see that the two here are parallel and the other two are parallel. Okay, so on these problems in your journal on page 104, they gave you two lines, 2 points, and this is a line containing these 2 points, this is a line containing these 2 points, etc. What do we have to do in order to find out if they're parallel? We could graph them, or we could use the slope formula to find the slope. So I'm going to do that for you. There's the slope. This is the slope for B, and we can see that line A is parallel to line C because they have the same slope. And we can do the same for number 4. If you want to try it first, pause the video, and we can see that, whoa, none of them are parallel. You can always check your math again, but none of them are parallel. Now look at the next couple problems. What do we need to do here? We need to put them in slope-intercept form. Okay, we don't just look for the number that's attached to the x. We have to have it in the right form in order for it to give us our slope. So I'm going to do that for you. And you can try the next one, but now that I've got them in slope-intercept form, I notice that this one does not match either of the others. This one has the same slope as this one, so B and C are parallel. So this is a rule that's going to help us with our next problem. In a parallelogram, opposite sides are parallel. This side is parallel to this side, and this side is parallel to this side. So it says use the ordered pairs of the slope formula to find the slopes of MJ and KL. So the first thing you're going to do is find the slopes. Okay, so they found the slope of MJ is 4 and the slope of KL is 4. These are both horizontal lines, so we know that they are parallel. So since that one says that they're parallel because they're horizontal lines, there we go. And since opposite sides are parallel, JKLM is a parallelogram. Okay, so in this problem, they want you to write an equation in slope-intercept form for a line that passes through the point 3, so let's draw this, 1, 2, 3, -1, and it goes through, it's parallel to this line. And so let's draw that line, 1, 2, 3, and then go up 1 over 1, 2, 3. So this line looks like this, and they want you to create a line that is parallel and goes through this point. Now never assume that your graph is going to be accurate. So how are we going to do this? And here's your hint. We're going to use the point slope form. So I'm going to take the slope from the equation they gave me from the original one, because I know that since they're parallel, they'll have the same slope. So my parallel slope is 1/3, and the point is 3, -1. So y minus -1 equals my slope that I know is parallel, x minus 3. I zip zap that, I get, so you go like this, and I get, distribute the 1/3 x minus 1. Subtract 1 from both sides, y equals 1/3 x minus 2. That is the equation of this new line that is parallel to my original line and goes through the point 3, -1. And notice I did a pretty good job drawing it because it goes through -2 as the y-intercept. You do not need to graph these problems. In fact, I suggest you don't. Just do the problem in point slope form. Okay, so let's try another one. First thing we're going to do is we're going to steal the slope. Okay, so our slope is -2, and we're going to use that point that they gave us. We're going to use the point slope form. Y minus our y and our point equals our slope times x minus the x of our point. Zip zap this, we get y plus 2 equals -2x plus 2. Negative times a negative. Now I'm going to subtract 2 from each side, and I get y equals negative 2x. I don't write the plus 0. Okay, these cancel. This just means it's a direct variation line going through that point with this slope. That's all it means. It does not have a y-intercept. The y-intercept is 0. Okay, it does have one, but it's 0, so we don't need to write it. Okay, now we're going to talk about perpendicular lines. Two lines in the same plane that intersect to form a right angle are perpendicular lines. Non-vertical lines are perpendicular if and only if, and this is an important point, their slopes are negative reciprocals. Vertical lines are perpendicular to horizontal lines. Here's a picture of that. Okay? Two lines are perpendicular if they intersect at a right or 90-degree angle. The product is the other part of it. The product of their slopes is negative 1. So if you look at these two slopes, negative reciprocals, meaning it's the reciprocal but the opposite sign, and then if you multiply, you get negative 2 over negative 2, or negative 2 over positive 2, which is negative 1. Okay? All right, so here we go again. So this is the negative reciprocal. Look at these. Okay? So you can see that they're reciprocals, but one has a negative sign and one is positive. That's what is meant. You'll hear them called negative reciprocals or opposite reciprocals. They mean the same thing. Opposite sign reciprocals. Reciprocals actually have the same sign, so that's why they have to say opposite reciprocals. The other thing they tell you is that if you multiply them, you get negative 4 over 4. They equal negative 1. So the slopes will equal negative 1. Opposite reciprocals. Okay, and this says if you know the slope of a line, the slope of a perpendicular line will be the opposite reciprocal. Flip over 2/3, give it the opposite sign. 1/5, flip it over, and it's negative 5. Negative 7, flip it over, it's positive 1/7. Okay, so determine which of the lines, if any, are either parallel or perpendicular. So first thing I'm going to do is I'm going to find my slope. So for this one, I'm going to use these 2 points. 1, 2, 3, 4. 1, 2. This is going negative. So this one is negative 4 over 2, which is negative 2. Okay, this one here is 2 over 1. 2 over 1, but it's also negative. I can see that by the little man running. So that's negative 2. So this one and this one, these are parallel. And now to check this last one, let's see if it has a negative reciprocal. It's 2 over 2. So the slope of this one equals 1. So it's not perpendicular to either one. Now ask yourself, what would the slope be of a perpendicular line? The slope of a perpendicular line would be positive 1/2. Okay, so just remind yourself of those kind of rules. Okay, let's look at the slope of this one. It's best to use points that they gave you. So 1, 2 is my run. And my rise is 1, 2, 3, 4, 5, 6. 6 over 2 equals 3, and it's positive. Okay, now I'm going to check this one. Boy. 1, 2, 3, 4, 5. Right away I can see, and it's over 2. It's 5 over 2, so these are not parallel. Okay, now I'm going to check this one, see if it's parallel to either of them. I think I better change my color because of all those extra lines. So I'm going to go down here and over. Okay, so I've got a rise of 2 and a run of 1, 2, 3, 4, 5, 6. And it is negative, so it's negative 1/3. So we can see that this and this, these two lines are perpendicular. This is line B, and this is line A. Okay? All right, so now in this one, they are asking you to find out if they're parallel or perpendicular. So you have to do all the slopes to double check. Okay? Now, the answers are going to pop up. I want you guys to understand what you're finding here. Okay? So, I've got -1, I've got 3 over 2, and I've got -3. None of those are the same, and none are perpendicular, so there are no parallel or perpendicular lines. Okay? All right, over here, let's look at these answers. And you can stop and work them out if you want. Okay, first thing I noticed, these have the same slope. So therefore, A and B are parallel. Okay? Now, for these, they're not all in slope-intercept form, so make sure you get them into slope-intercept form. This one I have to divide everything by -3. This one I have to divide everything by 4, because y has to be alone. Once I do that, I get my slopes. Look carefully. This one is 3/4, this one is -3/4, therefore they are not negative reciprocals. This one is -4/3 and this one is negative, so they're not perpendicular. So now compare these two. Are 3/4 and -4/3 opposite reciprocals? Yes, it looks like it. Now multiply them. I get -7 over 7 equals -1. So line A and line B are perpendicular. Okay? Over here, we've got to do a lot of work. If you want to stop and check yourself, these they gave, we can see right away they gave my slope because they're in slope-intercept. They are reciprocals, but they are not opposite reciprocals. So now we're going to do line A to see which one it's the opposite reciprocal for. So, and those, I gave you the slope there, and we can see that these two are parallel. So A is parallel to C. And I mark the slopes for you there. Okay? All right, so how would I show that ABC is a right triangle? Well, we know that a right triangle has a 90-degree angle. And what we've learned today is that we can prove that something's 90 degrees if the slopes are opposite. So I'm going to find the slope of AB, which is a positive slope of 2 over 3. So the slope of AB equals 2 over 3. I'm going to do this one. And 1, 2, 3 over 2. And this one's negative. And the slope of AC is -3 over 2. Therefore, this is a symbol for therefore, AC is perpendicular to AB. Sorry about my little extra lines. And so ABC is a right triangle. And this is kind of preparing you for proofs later on, but it's just showing you how to set things up, how to prove things. Okay? Okay, in this problem, we're going to write the equation in slope-intercept form for a line that passes through the point -2, 2, which is right here, okay? And it's perpendicular to this line. And I went ahead and graphed it for you so you could see. The thing about doing this, if you tried to graph it, is very, very difficult to graph a perpendicular line. So that's why it's really important that we use point slope. But the extremely important thing to remember is that you want a perpendicular slope. And the perpendicular slope would be 3 over 2, and it's going to be negative. Okay? So now we're going to use that point and the point slope formula. So we're going to go y minus 2 equals our new slope times x minus -2. So y minus 2 equals, don't forget to zip zap, so that's now a positive 2, -3 over 2x. Distribute the -3, the 2's cancel, we get -3. So I'm going to add 2 to both sides, and I get y equals -3 over 2x minus 1. And so it should go through that point And now we could draw our line using a ruler because we know where the y-intercept is, and it'd be a lot easier. Okay, so the final equation is y equals, see if I can write this without those pesky lines, and there it is. Don't forget the negative. Okay, again, this one, we're ready to go. We know what to do, but this time there's a warning. Don't forget you need to have it in slope-intercept form. So I need to divide everything by 2. My equation is y equals 2x minus 3 over 2. All I need is the slope. I'm going to get my perpendicular slope, which would be negative 1/2, the negative reciprocal or opposite reciprocal of 2, and then I'm going to use the point. So I go y minus 1 equals negative 1/2 times x minus 3. Y minus 1 equals negative 1/2 x plus 3 over 2. Okay, now we're going to add the 1 to both sides. Remember, 1 is, and we're going to add 1 to 1.5. So we get y equals negative 1/2 x plus 2.5. You can write it like this. You can write it any way you want. Okay, just make sure you make it 2.5. Okay, so how would I show that WXYZ is a rectangle? So what are the properties that you know about rectangles? They have 90-degree angles and opposite sides are parallel. Are these things that we've learned how to show? Yeah, we can just use the slope. So you're going to find the slope of each side, 1, 2, 3, 4 over 1. So 4 over 1 is the slope of this side. And I did the same thing over here and found the slope. So now I know that XW is parallel to YZ. Okay? Then I'm going to find the slope of this side, and that is 8 over 2, but it's also a negative slope. So it's, I did it again, the rise is 2, the rise is 2, so it's negative 2 over 8, which is negative 1/4. Then I'm going to find this one, which is also negative 1/4. So I just showed that XY, XY is parallel to YZ, okay? And then because these have opposite reciprocals, I now have proved that XW is perpendicular to YZ, and you can go through each step, finding each corner and opposite. Now that you've got the opposite sides are parallel, but you also have the slopes, because so you can show that they are opposite reciprocals. So you just go through every step. And that's, you can finish that up, but that's all we're going to do for now.